Let's take a look at week 10, example 2. In this example, we're being asked to find the cosine of 15 degrees, the tangent of negative 15 degrees, and the sine of 7.5 degrees. While none of these are angles for which we directly know our trig values, they're all closely related to some angles for which we know our trig values, so we can use our identities to get the rest of the way. Importantly, it seems to me that 15 is half of 30, and I do know all of my trig angle or trig values associated with an angle of 30 degrees. Therefore, it seems reasonable to me that I would like to use the half angle formula associated with cosine. We've derived in the notes that the half angle formula for cosine is plus or minus the square root of 1 plus cosine of theta divided by 2. In our case, the half angle is the 15. What is it half of? The angle that we actually know things about, 30. So notice in our formula here, this angle is half of this angle. 15 is half of 30. So that allows me to rewrite this as cosine of 15 equals 1 plus cosine of 30, all divided by 2. Notice that this formula and all of the half angle formulas all come with a plus or minus here. However, the thing that I know is that 15 degrees, cosine of 15 degrees should be about here. We're always going to have a positive width that's associated with 15 degrees. So I'm confident that we are choosing the plus out of the plus or minus option right here. Every time you use the half angle formula, it will be your responsibility to decide, should I keep the plus or the minus? It'll never be both. You're always just going to pick one, but we can always stop and think about what sign should this have in our unit circle. In this case, we're choosing positive because I know that the cosine of small angles like 15 degrees is always going to be positive. The good news is we don't really have much work to do here. All we need to do is evaluate cosine of 30 and do some simplification. Honestly, I think the algebra is the toughest part of this problem right here, the simplification. I know that cosine of 30 is root 3 over 2. And so in a sense, we're done. This is the number that represents our final answer. I'd just like to do a little bit more simplification to clean this up a little bit here. First, I'm thinking to myself, I've got a fraction within a fraction. I'd like to clean that up a little bit. So I'm going to say I have 1 divided by 2. Also, root 3 is currently divided by 2 once, and we're dividing by 2 a second time. So it's being divided by 2 twice, also known as being divided by 4. I can then get a common denominator. I'm going to go ahead and think of 1 over 2 as 2 over 4. And so we should be able to write 2 plus root 3, all divided by 4. As my final step in my simplification, I could apply the square root to either the top or the bottom individually of this fraction. I don't know a better way to write 2 plus the square root of 3 as a square root, but I do know how to take the square root of 4. So as my last step here, I'll write this as the square root of 2 plus root 3, all divided by 4. Our answers for these often end up looking a little bit crazy, so when you compute some of these exact values using half and double and sum and difference formulas, it's always good to go to your calculator, compute this value in your calculator, get a decimal, compute this value in your calculator, be sure that you're in degree mode, get a decimal. If you can confirm that they're the same, then you should feel good that you've got the right answer. Let's go ahead and take a look at the second part of this example, computing tangent of negative 15 degrees. Again, since 15 is half of 30, I'm going to go ahead and apply a half angle formula for tangent, and I'm going to use my known angles of 30 degrees to help me figure out what's going on at 15 degrees. In the notes, we derived the formula, the half angle formula for tangent, and it was given here as plus or minus 1 minus cosine of theta divided by 1 plus cosine of theta. Here, again, we're thinking of half of the angle being negative 15. We're thinking of the whole angle then being negative 30. So I can rewrite my expression here. As with our last example, we need to make the choice about plus or minus. If we think about where negative 15 degrees is located on the unit circle, we can see that the cosine value is positive, but the sine value is negative. Therefore, when we think about our sine divided by cosine, there should be one negative involved, so I will get negative values associated with this tangent here. We also have some negatives to contend with within our cosine statements here. We want to remember from our symmetry discussions, when we look at negative 30 degrees here, the thing for me to recognize is that negative 30 and positive 30 both have the same cosine values out here. Their sine values are different because one went up, one went down, but their cosine values are equal because they both went to the right by the same amount. What that says to me is that the cosine of negative 30 degrees is the same as the cosine of positive 30 degrees. I further know the cosine of positive 30 degrees is going to be root 3 over 2, so I can go ahead and make some substitutions now into my half angle formula for tangent. Once again, as with the last problem, in a sense, we're done. This number should be the number that we're interested in. I just tend to never leave final answers in the format where I have fractions within fractions. We're actually going to have a couple good algebra steps that we can do to clean some things up here. So the first thing that I'd like to do is I would like to say, I don't want to have these fractions anymore. I'd like to clear these fractions here. Since I currently have a division by 2, I can undo that with a multiplication by 2. So my thought is I'm going to multiply the entire numerator and the entire denominator by 2. 2 over 2 is 1, so this is a legal move. Multiplying by 2 on top and on bottom should go ahead and clear those fractions. And this does give us a much cleaner form here. The next move that I'm going to do is considerably less obvious as to what we should be doing here. We've had several discussions about simplifying, whether we care to do it, whether we don't. Hopefully this will be a good example as to why people do like continuing simplification from this point on here. Whether this is fully necessary is debatable, but I do want to show you how I got to my final answer here. What I'd like to do is rationalize the denominator. Currently the denominator is irrational because we have a square root term in the bottom down here. We would like to make it rational, meaning I would like to have no root terms on the bottom. Well, a good way to get rid of root terms is to square them. We undo square roots with squares. I can't directly just square the top and bottom, but I can multiply top and bottom by the same quantity. So what I'm going to do here is I'm going to multiply our entire expression by 2 minus root 3 and 2 minus root 3. The reason that I'm doing this multiplication here, first we should notice that this is simply 1. It's the number divided by itself. The square root of 1 is 1. So this is just a fancy version of 1. The reason I'm choosing this value is because when we multiply together these two terms in the bottom, we're going to FOIL these two things out, just like when you dealt with quadratics. 2 times 2 is going to give me 4. 2 times root 3, 2 root 3. 2 times negative root 3 is a negative 2 root 3. It'll cancel with the positive 2 root 3, our other middle term. And on the end, we're going to get root 3 times negative root 3. Well, that's going to be root 3 squared, which is going to just be 3. We're going to keep the negative sign that's attached to it, though. Up in the numerator, you should notice that these two numerators are exactly the same as each other. So since we're multiplying 2 minus root 3 times 2 minus root 3, I'll be able to think of that as 2 minus root 3 squared. So here's what my next line looks like. Some really nice things are going to happen here. Clearly in the denominator, we have a very, very simple expression now. 4 minus 3 is just going to give us 1. Square root of 1 is 1, so it looks like we're done completely with dealing with the square root on the bottom. Further, we're able now to take the square root on the top since we're taking the square root of a perfect square. So it looks to me like we're going to be arriving now at, again, The denominator is 1. We don't even need to track that anymore. Every number is divided by 1. Up top, we're taking the square root of a square. Those are going to cancel, leaving us just with that expression. Finally, I'm going to go ahead and distribute my negative onto both of these terms. So negative root 3 becomes positive. Positive 2 becomes negative, allowing me to write my final answer as the square root of 3 minus 2. Let's go ahead and take a look at the third part of week 10, example 2, computing sine of 7.5 degrees. The way in which this one's a little bit different than the previous is that we previously identified that numbers like 15 are half of 30. 30 is good because we know all of our trig values associated with 30 degrees. Our issue here is that 7.5 is not half of one of our known angles. 7.5 is half of 15, and I don't quite know a lot about 15. However, 15 is half of 30, so it seems like rather than just doing one application of our half angle formulas, we could do two applications to go from 7.5 to 15, then from 15 to 30, moving on down the line. Part of the reason why I chose this one, save a little bit of work right here, is that we've already found some of our trig values associated with 15 degrees, so we're actually going to get to reuse some of our work from the cosine of 15 degrees part when we do this problem here. So, as before, we're going to recognize that 7.5 degrees is half of a somewhat desirable angle to work with, 15. So I'm going to go ahead and set up my half angle formula associated with sine. Our half angle formula for sine is 1 minus the cosine of theta divided by 2. In our case here, the half angle is 7.5. If half of the angle is 7.5, then the whole angle must be 15. Once again, the plus or minus is always associated with our half angle formulas. You always need to make the choice. Again, I know that if we open up 7.5 degrees, then we are going to have a positive vertical rise, so I'm going to select the positive of the two values that I have to choose from. Again, we're here at a point where we plugged in all the known values. All we have left to do is evaluate. If we were doing this as a standalone problem, we would now need to stop and work out what is cosine of 15. However, that was actually the first part of this example right here. So I'm going to go ahead and reuse our old result here. We had previously found that cosine of 15. We found this value to be square root of 2 plus root 3, all divided by 2. So I'm going to go ahead and plug in this value, and we'll be able to evaluate from there. As with the last few problems, really our major roadblock here is just doing a little bit of simplification. I'm not going to go too far. I see that I have 1 divided by 2. I also have this quantity is already divided by 2 once and will be divided by 2 a second time. So I might write this as square root of 1 over 2 minus root 2 plus root 3 all divided by 4. I could probably do one more little line of work right here. This thing's getting pretty gross. I don't know how much value I have in simplifying this too much further. We should note maybe in this example right here that if you take this to your calculator, you will get the decimal approximation 0.1305. If you go ahead and throw sine of 7.5 into your calculator, you'll end up seeing the same value here. So again, kind of convincing ourselves that we did a good job, even though these exact formats kind of end up looking a little bit crazy with lots of applications of our some of our identity formulas here.